Welcome to today's live session at Digital South Africa. We are very grateful for you to join us. We have today the session on modeling dam volumes using Digital South Africa water bodies. It's a very good service that is really giving us very important insights. So Digital South Africa is working with partners across the continent, and we've been able to develop continental services, and the partners have helped us a lot in the validation. The water bodies came thereafter, the water observation from space, and these particular water bodies is very key to give us the information on the individual water bodies. So the continental services in that no particular order. The first one was the water observation from space, which was giving us insights over the 5 years. And now the water body service is giving us the data on individual water bodies, which is very key to unlock potential management of water bodies. We are working with partners across the continent, providing this analysis-ready data to help us in different national reporting, including Sustainable Development Goals. The topic today of modeling data volumes has been of interest, especially Digital South Africa launching the service 2 years ago and had engagements with the different stakeholders, especially the Department of Water and Sanitation in South Africa. So there was a need that they wanted to check some of the dams and possibly now collaborate on a model under the digital innovation digital twin for Limpopo River Basin, which is aimed at informing water management across this particular water body. So with the workflow we present, you are able to come up with your own also data, which is also very key. And then generally comparing to what we have for the water body service to do some model training and also create some estimates on the water. We have this in the use case folder. We have the Limpopo River Basin, and there you'll have 3 notebooks. The first one is on data preprocessing, which is very key for any work and project. The second one is on the model training the model to actually run for the area. And thirdly is to do the model prediction. So the integration of this data has been also captured in the various literature reports, including Retif and et al. In 2025. So in our Digital Africa map, we are able to look at the water body service, and we've come up with these unique identifiers, which are very key. And in today's presentation is on Loskop Dam, which is located in the Olifants River Dam in Mpumalanga, South Africa. And this particular case, we're able to unlock the potential. And looking at this particular graph, we're able to see some potential dates and when the years when we had some changes in the water bodies over time. So in this particular context, in our sandbox, we're able to go to the folder, and we are looking at these particular 3 notebooks. And in the first one, we are looking at the data preprocessing. And here we explain that this is part of the Digital Twin program under the SIJA initiative. This is a team where we have International Management Water, IEMI, and partners who've worked closely with the Department of Water and other stakeholders, and in Digital South Africa, bringing the value proposition of the water body service, which is very key to help us in getting more information. So on the other side, when we do the data pre-processing, is to first, locate the particular geo hash, one of which I was showing in the other screen, and we're able to locate the particular dam itself, and also as part of the workflows, we're able to get a surface area which has been wet, as particular this graph, and noting the fluctuations of the dam as occasioned by climate change and other repairs. And as time goes by, there are some repairs on the dam and also extreme weather events. Then also we're able to load the model data set and extract some attributes. On this particular case, there's some analysis parameters as part of this particular water body. You'll be able to see the calculated and what the level was recorded for the dam and what is able to be seen from space. There's quite some comparison. And over time, the models have become a little bit better based on time and also the data collected by the different teams. So in this particular case, just giving you an example, we are able to go to this particular notebook And when you scroll down, we're able to import the necessary parameters and the geo hash for that particular low-scope dam. So low-scope dam, and you're able to see the unique identifier, and also you're able to see the patterns in the water over time. And from that, we're able to load that particular data and overlay it on the base map. And from that, we're able to see its attributes since 1984. And from that, we're able to see the trends over time, especially some key insights in the particular dam. And based on that, load in some particular model parameters that would help us in looking at the sample data and looking at the variability of the water over time based on the volume estimates from space and also what was recorded. And much of this work has been on the data collection from the Department of Water and Sanitation as part of this particular program. And it shows a lot of collaboration with the different partners to get the right models, algorithms, and also making it very easier for other stakeholders who can just come in and borrow on this particular model, which has been trained, and looking at the volumes generated, and also looking at the different steps, and also looking at the calculated versus what has been shown from space over time. Quite some improvements over years because of collection data being done very often, and also contribution to the partners and the various scientists who contributed to this particular work. So when you look at the data, you'll see some test data, and also from that, you'll be able to see some of the results as you go, like the volume predictions generated for each year, each month. And from there, now we're able to go to the second step of the particular analysis. So in the second step now is to go to model training, which is very key for any model. So we've collected a lot of data, and also the model now we developed for the teams is to see how it works. And what happens is to load the various model training datasets, the data preparation, and also doing some tuning and fine tuning, and also testing the models. And when you test most of our models, we normally refer to the root mean square error in the range of from process validation, working from 90%, and when doing some fine tuning, going around good values around 70%. That is just for a big water dam, which is quite good. So in this particular case now, just to showcase to us is to see how to run the second part of the notebook. It is done series by series because it requires the data from the first step to the second step, and now doing the training of the model, and we're able to come up with some results, which now will feed into the third step. We are still relying on the same parameters and the same volume prediction. So from the model, we have just done the testing, and now we've calibrated the model. The next step will be now to actually run the model itself and look at its error evaluation. So in this particular case, just segmenting the items is to see that we're able to give an estimate of the predicted levels from what has been observed. And as was mentioned, generally over time, based on the policies of the government, there has been more initiative towards from the year 2013 onwards, and there's been a lot of data collection, which is comparing to what is predicted. And also there were times when this dam was particularly dry in the year 2016, 2017, 2018. This coincides with the time that was recorded the highest drought time, which affected South Africa. Also, we also able to see this in the Western Cape example. I'll be able to show you another example of the Butters Dam. So based on that, which was also observed, we are also able to see gradually an improvement, increased rainfall, and also good parameters and tested. So over time, based on what data has been collected, we are able to observe more data points were collected in the respective years that I've mentioned. And you can see quite some correlation in the model that is generated, which is estimated to give at least 95% based on the data collected and what Digital Africa Waterbodies is providing. So in this particular case, please let me just show you this particular notebook and you're able to run it. Different parameters. So these three items are key: the rating, the daily volumes, and all that. And also, mind you, we generated some parameters in the first and second notebook, which now will be used in this particular notebook, where we actually show you between the observed and the predicted, where we are seeing quite some correlation. And we are going to the value of almost 95%. And this is also a testimony of the work done by the different officials at the Department of Water and Sanitation in providing the data sets, and also the improvement of the data collection over time, which is also good for them to do the monitoring. And you can see the predictions generated and the observed volume. And from that, we're able also to see that what we are seeing, the training models and how it was actually able to generate and the results. And from this, we're able to see quite some work done by the Department of Water and Sanitation, providing all the attributes, and also going to the South Africa map, be able to see the exact area and the map and the particular specific water body. And this is just one of the use cases that Digital Africa is very grateful to showcase as a collaboration with the Department of Water and Sanitation. So also thinking about it with the water bodies, what else can we do? We're able to look at seasonal animations, which are giving us an opportunity to compare with what we have in the Sentinel-2 GeoMat, cloud-free mosaics, and also adding some attributes of rainfall data. So as you can see, the water observation from space and also the CHAPS data on the rainfall. So this is the seasonal animations. So we're able to go to the notebook in a real world example, and we're able to run and import the different attributes, our area of interest, the specific coordinates in Mpumalanga, Limpopo, the border, the Scoff Dam. And with this, we're able to get the initiative, the geohash, which is collected from the South Africa map. Which one is, this one is here, that is a particular attribute. And from that, now you're able to work on a specific water body, which is very key. So there's a lot of applications in the water bodies, especially looking at examples by our Digital Africa champions, like Rodrigue, who was looking at some dams in Burkina Faso. So in this particular case, we can see this Loskov Dam, plotting it and the rainfall. We are seeing this correlation, the droughts and increased rainfall, and also greater management of this particular dam. Then also we're able to compare with another dam, Bokloroi Dam in the in Niger River. And in this particular case, we're able to load it, and that is the particular geohash, that particular water body. Then we're able to couple it with rainfall data. And then finally, we're able to come up with the animation, which shows you how the trends have been for this particular water body. So it's really helpful to see how more we can tap into other existing research. So this is the animation generated on the seasonal animation. So for the Loskop Dam in South Africa, we can see just the trends in the plot, where there's increased rainfall and where there's decreased rainfall. The dams is a little bit lower because there's, of course, evapotranspiration. So it's quite useful to give insights in the water management. Still on the same, we have the long-term animation in the Africa, which will give you the trends, and you can see over time the plot on the water bodies and the extent, and noting the dry points 2017 noted. So this is also an example of how we can monitor the water observation from space, as we were showing the water body service only. So water observation from space was the first service developed by Digital Africa, and this one gives you over 35 years of data, and we're able to get the insights at this particular water body, the same one, and you can see the trends over time since the 1980s to the 2000s. You can note the increase and the decrease of this particular water body over time. So looking at the plot, we're able to see the increases and the steady decreases over time. So this one we can actually generate for any water body across the continent, as you can be able to type your question in the chat and we can be able to explore how that one looks from the other side. So we're able to get very interesting insights over time. And also as I get more ideas, so mostly dams because these are closed water bodies, or even small lakes like Lake Bosum Chui in Ghana, for example. So those small water bodies. So we also have the use of the water index and the Sentinel tool, where we're able to capture the same, but for this particular dam or water body, and we're able to see the specific water index. So we are going back based on the Sentinel-2 data provided from 2017, and we're able to see those particular insights when it was drying, and generally over time, it was able to recover in terms of recharge. Then also from this, we can be able to see the animation, which can be very key for you, especially when you're presenting to high-level audience, to give them the insights on what has been happening over time and how the situation is and how the extreme events are actually affecting this particular water body. You can even see the observed seasonal variation from space, key areas and key dates shown and increases. So the situation will be different, especially if we are looking at the Rift Valley lakes, where there's been the other way around of increase or even sometimes flooding. So also in the learning platform, we have the course on the water resource and the water bodies, which is very key to see where we can get additional resources in the learning, the platform, and also on our website. We have the introduction to Sandbox, the user guide, and the weekly live sessions, for example. Then in the learning platform, you can see the courses when you explore the water bodies, etc., etc., the introduction to Sandbox course as well. And of course, I'll be able to do another short demo of another water body so that you can see how we can continually expand our skills and research. So the user guide is also nice because you can click on specific water bodies. So you can also see applications in the WebGIS, also Africa Geoportal, and also accessing via the direct access as well, which is very key in case you do other research, and also everything is just step by step. And also on our website, the live sessions are recorded and provided every time. The focus areas and also access to the platform and the continental services, which are very key to us. And also, just as a summary, our live sessions in English and French, and also when I do another share also is to see if we could do another short demo as well on this particular use case on the example for the water bodies. So on the water bodies, we have through the Digital Africa map, be able to show you once more is that we be able to show the particular water body again, where now in the Africa maps, we can be able to load the surface water bodies, and you can see the load for the whole continent. And looking at just examples based on our participation, we could just look at, for example, Lake Bosum Chui on Kumasi area. So for example, we are able to see around, so we could also put some tree, or we could just load the big city around Kumasi, and you're able to just go to the area, and also now you're able to pick Bosom Tree, and you can be able to see the particular water body and its particular identifier. So this is just showing you the trends over time. And also just to move into the example of Burkina Faso, because of our colleague Lele, sometimes when you move, you can always disable the background and now go specifically to a specific country and look at some of these particular water bodies, Le Barrage. So there's one near Yako, there's one also changing the map settings in the background also can help us because then we're able to load the background quite faster, for example, and you can be able to get more insights on the specific water bodies. So you can see the trends and you can even see possibly the dates when the particular dam was developed. So this is quite informative insights. We can also go to another one here and get just some more details. So you can see possibly it was constructed then, but the water now was a little bit built up later on with time. So the water bodies really helps us to get those insights, and just finally ending with an example where we could have occasional floods in one of these water bodies would have been Lake Baringo, because this one now presents a very interesting water body, which fairly was drier in the other years, but over time in the 2019-2018, they experienced a lot of flooding, and now it's at its highest peak. So we can also validate this with the water observation from space, where we put in the all water summaries, and we can change the legend. Also on this one, should you need only to narrow on this particular one, you can expand it so that you only remain with one. So you can even have more details about it. Then on this other side, we are having it on the being loaded first. And you see it's the only one which is loaded now. And then I can have the particular water observation from space, which will give me the particular trends for this particular body from the blue to non-blue. Should you also want to get more details, we can now add in the water observation for the annual summary, which now will give you the water summary by year. So this will be an interesting one as well. So based on this today's use case, that one was based on the data which was provided by the particular stakeholders. So moving also from different dates is very key because we can see the trends over time. For example, moving from the different years, we could move from that 2017, 2016 and just see over time the trends, and also you can play the slider to get just the information as it has changed over time. So sometimes also it's based on your internet connectivity sometimes, and also the trends over time, the way they change. So this one, we can just move into specific dates, just going to the, for example, what was in 98. We can also choose now from what was 2000 to 08, for example. And it just generally over time, it will be able to load. And also now going to the other years, so based on your internet connectivity. So I wish also, just as we conclude, just to going back to where we were, is to give you the overall guidelines, and also the upcoming sessions that we'll have. We'll be looking at enhanced drought index at country level and acknowledgement of our partners, Helmsy Trust and Australian government and other partners. And also thanking you for being with us at this session, and also that will be able to connect with you to provide further demo on the same. Thank you so much, participants.